We didn't get me swearing on there. I'm like, we've just like 10 minutes into class managed to get started and there's an interruption. But anyway, write this as a write this as a conversion factor. How do we do that? We're focusing now. How would we rate this as a conversion factor between atoms and molecules? There are 2 O atoms for every 1 CO2 molecule. And remember, MC, capital M, capital C stands for molecule. That's not an official abbreviation, that's a Ms. Spence abbreviation. There is none. Yeah. So if you're at like university or something, or you're studying chemistry somewhere, you might want to ask your professor, or whoever's marking your stuff, what you can use instead of writing out the whole word, because it's just far too long. Okay. Now, okay, we have a little lovely conversion factor here. How many atoms of oxygen are there in 3 molecules of CO2? There are 1, 2, 3, 4, 5, 6. What we are going to be doing is we are going to be showing how to do this using a conversion factor. Okay? And I know it seems silly to do this, but you're not always going to have numbers that are this small and easy. Okay, so let's just show how we do this. We have 3 molecules of CO2. That is our initial quantity, is 3 molecules of CO2. In order to convert, what do we need to put on the bottom? We want to find the number of O atoms, or atoms. Nobody got that? That's all right. What unit must we cancel? Molecules of CO2, and we want to find O atoms. And we know that there are 2 O atoms for every 1 molecule of CO2, and so we'd cancel those out and we get 6. So that's how you would show the work. Next, how many CO2 molecules could you make? In this case, could you make if you were given 8 oxygen atoms? So here's our 8 oxygen atoms. 1, 2, 3, 4, 5, 6, 7, 8 oxygen atoms. How many CO2s can we make? 4. 1, 2, 3, 4. Yeah. So now we're going to show how we would do this using a conversion factor. Our unknown is how many CO2 molecules. Our initial quantity is 8 oxygen atoms, so that's what we're going to write down here, 8 O atoms. So we now need to cancel O atoms and find CO2 molecules. And there are 2 O atoms in every 1 CO2 molecule. So 8 times 1 divided by 2 is 4. CO2 molecules. So that is how you would show the work for that using conversion factors. Is good? Okay. Can I scroll? Nobody's saying no, so I'm going to say yes. Okay, we have a molecule of methane here. Here's methane. All right, methane. And its formula is CH4. We are going to write conversion factors between molecules of methane and atoms of H. So how many atoms of H do we have for every molecule of CH4? 4. How many carbon atoms in a CH4? There's 1 carbon atom, or catum. Yeah. And O atoms are OTOMs. Yeah. For 1 molecule of CH4. CH4. And now, can you do this one? What is the ratio between the atoms of carbon and the atoms of hydrogen? There's 1 atom of carbon for every 4 atoms of hydrogen. And you can either write carbon atoms or atoms carbon. You can write molecules CH4 or you can write CH4 molecules. It doesn't matter which way around you write those, okay? We are now going to use these 3 conversion factors to solve the following. How many carbon atoms are contained in 128? That's our initial quantity. And our unknown is the carbon atoms. So we want to find the number of carbon atoms, and we are starting with 128 CH4 molecules. Is it? How many carbon atoms, not hydrogen atoms? Yeah, how many carbon atoms? Yeah, because there's 1 carbon atom for every 1 CH4. And I might even leave off the molecule there. I don't need to write molecule. There's 1 carbon atom for every 1 CH4. And we get 128 carbon atoms. How many hydrogen atoms? And be sure that when you're writing this down that you're showing your work using the this over that and showing your unit cancellation. Because like I said, when we're doing this, they won't be this easy always. So we now have 128 CH4s times, we want to cancel CH4 and we want to find the number of atoms or hydrogen atoms. It would be 4, and this is where we get to, what was that number you had for us, Nathan? 512, 512 H atoms. Woo, what happened there? That was exciting. Now this one's a wee bit, tiny bit trickier. What if I start with 128 hydrogen atoms? And I'm just bringing up this word because it comes up in grade 12 and people don't know what it means. Sufficient carbon atoms. Sufficient simply means enough. So I'm going to give you only 128 hydrogen atoms and as many carbon atoms as you need. You can. How many molecules of CH4 could we make? Well, now we are starting with our initial quantity is the 128 hydrogens. And what we don't know is the number of CH4s. So we want to find the number of CH4 molecules. And we are starting with 128, sorry, 128 hydrogen atoms. So we know that we need to cancel, whoa, that wasn't good. We know that we need to cancel hydrogen atoms by putting it down here. And we want to find CH4 molecules, so that's going to go on the top. What number has to go on the top and what number has to go on the bottom? 1 goes on the top and 4 goes on the bottom. And what do we get when we divide 128 by 4? We get 32 CH4 molecules. Now you'll notice I haven't gotten excited about significant figures here. And that's because these are all countable numbers. I could, in theory, count out 128 CH4s. That would make a CH4, that would make 128 an exact number because I've counted it. Yes? Are these numbers exact numbers? Yes, because there's exactly 4 atoms and exactly 1 molecule. So when we're dealing with relatively small numbers, like that don't have powers of 10 in them, you can assume that that number of molecules, if we're dealing with molecules, those are counting numbers, and so they are exact. But if I give you a number of moles, remember a mole is a great big, huge number, those numbers will no longer be exact because it's like, you know, if I say the budget for healthcare in this province is 9 billion, which it's not, but let's pretend it is. Okay, 9 billion. Does that mean it's exactly 9 billion? No, because a billion is a really big number. Yes, so there's going to be a little wiggle room in there. So if I say 9 moles, again, a mole is a really huge number, so there's going to be some wiggle room in there, right? We don't know that it's exactly 9 moles. It could be out by a bit. But if I say 9 molecules, is that exact? Yes, because I could count 1 molecule, 2, 3, 4, up to 9. Now we have 128 H atoms. That's our initial quantity. How many carbon atoms would you need to react completely? Exactly. And how did you get that? Yeah, so we don't know how many carbon atoms equals times, and what do we have? Yeah, 1 carbon atom, 1 catum for every 4 atoms. Okay, and we get 32 carbon atoms. Is good? Okay. Converting ions and formula units. It's the same thing. It's just that in this case, you need to start putting charges on things. Because if it's an ion, it needs to have a plus sign or a minus sign. So we have our formula unit, our single unit of our ionic crystal lattice. Crystal lattice. Crystal lattice. Break your teeth on the salad. So here is calcium phosphate, and you can see I have written out one formula unit of calcium phosphate where I have 3, see how we have a 3 there? 3 calciums, and we have 2 phosphates. So here's our phosphate, here's our phosphate, so there's 2 phosphates. How many calcium ions are there in one formula unit of calcium phosphate? 3. Super hard. Let's write that as a conversion factor. There are 3 Ca ions in one calcium Ca3PO4. And you can write formula unit, you can write molecule, or you can just write Ca3PO4. Okay? Question, have I done something wrong here? I've missed something. What have I missed? Not yet. Good guess though. Charges, because the calcium ion needs to have a charge. Okay? So if you have 16 formula units of Ca3PO4, and by the way, if you find the term formula unit too weird, you can just call them molecules. Yes, sorry. Oh, I forgot my, that? Yeah, okay. I was like, what does she see? Oh, I see where, yeah. Okay, so I got my formula wrong there. Yeah. If you have 16 formula units of calcium phosphate, so that is our initial quantity, how many calcium ions do you have? That's our unknown. So we don't know the number of calcium ions. We are starting with 16 calcium phosphate. And you can just leave it like that if you want to, calcium phosphates. We have 16 calcium phosphates. What do we need to multiply by? What goes on the top? Calcium ions. And on the bottom goes Ca3PO4. Oh, that's a weird looking 2. 2. And there are 3 calciums for every one of those. And so what do we get as our number? No. These are my grade 9s. You're good. What's 3 times 16? Is that 48? Cool. How many phosphate ions are there in one formula unit of calcium phosphate? There are 2. Okay, so we have 2 phosphates. And it's not just PO4, it's PO4 3 minus. So we're going to write that as a conversion factor. There are 2 PO4 3 minuses for every 1 calcium phosphate. And you can write the word ion here And you can write the word formula unit, which has the unfortunate abbreviation of FU. I'm sorry. So, or you can just leave those off altogether. As long as you're writing the charge, we know it's an ion. Okay, so you don't need to say ion if you've put the charge on it. And if you write CaPO4, you don't have to write formula unit there. Okay. Who is the initial quantity in part F? Who is the initial quantity? 18 PO4 ions. So we have 18 PO4 3 minus, don't forget the 3 minus, ions. What has to go on the top? And what has to go on the bottom? Formula units go on the top. So we have formula units, and that's going to be your Ca3PO4 2. And on the bottom go PO4 3 minus ions. And there are 2 phosphates for every 1 calcium phosphate. 18 divided by 2 is 9 Ca3PO4 2. What is the conversion between calcium and phosphate in calcium phosphate? Remember, it's still Ca3PO4 2. How would we write the conversion factor between the 2 different ions? There are 3 what? 3 what? Calcium for every 2 PO4. Are we happy with what I've written? What did I forget? The charge is 2 plus and 3 minus. Do not forget the charges. No, you have to write ion. You have to write the charge anyway, even if you write ion. Okay. How many phosphate ions would it take to react completely with 6 calcium ions? So what's my unknown? Phosphate ions. So I want to know the number of PO4 3 minus ions. That's what I don't know. What am I starting with in this question? We are starting with 6 calcium ions. Okay. And our conversion factor to get there, what unit has to go on the bottom? Calcium ions, that's going to cancel out. And on the top goes phosphate, PO4 3 minus ions. And there are 3 calciums for every 2 phosphates. So 6 times 2 is 12. Divide by 3 is 4. And the units that we are left with is PO4 3 minus ions. I'm going to leave this page for you to try, okay? But we're not going to do that right now. We are going to, in fact, we're going to skip ahead And I'm going to let you go back and practice those once we've done this together. So we're skipping ahead to 5.1H, which is on page 20. Well, you know, I often do that, you know. Page 20. So I hope all of you did your homework, which is pages 9 through 12. Did we all do that? Okay, and that homework was about Avogadro's number, which gives us the conversion factor, 1 mole of particles. Avocado's number, from which we can make guacamole. 1 mole is 6.02 times 10 to the 23 particles. And we have now learned that you can also use this, what we've just been doing is called the particle ratio. It's the ratio of atoms to molecules or ions to formula units, and you just count them up. This one you have to count from the formula. Okay? So what we've got here is we're going to be doing some multiple conversions. And in fact, just before we do this is 5.1H, I wanted to show you, is it this one? No, it's this one. This is on page 1 of your book. This is everything we will do by the end of this unit. Okay? So if you need a guide for where to go, this is all on page 1. And what it allows you to do is it allows you to start with moles. And for moles, you can go one of two directions. If you have moles of atoms, you can convert directly into atoms. But if you have moles of molecules, then you have to go from moles of molecules to the number of molecules, and then you can go to the number of atoms. So moles of atoms, you can go to the number of atoms. Moles of molecules, you can go to the number of molecules. Moles of elephants, you can go to the number of elephants. Moles of elephants' feet, you can go to the number of elephants' feet. But if you wanted to find the number of elephants' feet and I gave you moles of elephants, you would have to go from moles of elephants to number of elephants to number of elephants' feet. Yes? So this is our little place where we can always go and look things up. But for now, we're just focusing on when we have moles of molecules, we can convert to the number of molecules, and from molecules, we can count up the particles like we just did and convert to the number of atoms. Okay? So we can use this to make a map for ourselves. Whether you choose to make a map for every question is entirely up to you. It is not a required step. But what you can do is you can say, I want to know how many O atoms. So that means this is my ending point, right? My number of atoms are in 3 moles of sodium phosphate. So I'm starting here. This is my starting point. So I am starting with the moles of sodium phosphate. And if I have moles of sodium phosphate, I can convert that to the number of the same thing, sodium phosphate. And then from there, I can count the number of O atoms in sodium phosphate and go to O atoms. Shall we do that one together? All right. The number of O atoms is our unknown. We are going to start with 3 moles of sodium phosphate. So that's 3.000 moles. And remember, you can abbreviate moles as MOL, because that one little letter E, so much more writing, right? 3.000 moles of Na3PO4. We now have a 2-step conversion, 1 step, 2 steps. So we're going to have 2 conversion factors. So we can convert 3 moles of Na3PO4 into the number of Na3PO4. So we need to cancel moles of Na3PO4. And we are finding the number of Na3PO4. So that's going to go here. So we have just Na3PO4. Then finally, we want to cancel the Na3PO4s. How many O atoms are there in Na3PO4? And I really did not leave myself enough room here, but that's okay. We'll make it work. So I'm going to be canceling this out. I'm going to be canceling out the just plain old NO3. This is formula units. You can think of that as molecules, though, if you like. What numbers are going to go in here? What number goes with the mole? 1. In fact, almost any time until we get to stoichiometry, when you have moles, it's always going to be 1 mole, okay? When you're doing it as a conversion factor. And what number goes with the formula units? And this is why I said I did not leave myself enough room. Yeah, we've got 6.02 times 10 to the 23. Okay, so I've sort of squashed it in there. Okay. That's going to take us from moles to number of Na3PO4s. And then we're going to go our second step and say how many atoms are in there. Well, there are 4 O atoms, so we're going to have 4 times as many O atoms. So plug that into your calculator, see if you remember how to use your exponent button, and see what you get. .224 times 10 to the 24. Is that what you guys got? Did I punch my buttons right? No. Okay, so let me try that again. 3 times 6.02 E23 times 4 equals, oh yeah, that's what I got too. Uh-oh. Plug it in again. See if you punched a button wrong or if I need to come over and see what you're doing. Remember, this is all one number. I just wrote it in 2 lines because I'm silly. Did you get it now? Okay, am I done? What do I need to do with this answer? I need to round it to correct sig figs. Now, we have how many sig figs in 3.000? 4 sig figs. And we have how many sig figs in 6.02 times 10 to the 23? That is 3 sig figs. That always has 3 sig figs. So it will often be your limiting factor, okay? How about this 1 mole? Is that an exact number or is that like an estimated number? It's exact, okay? Because we're like, there's 1 mole and I have an estimated number of particles in it. We actually have an exact number of particles, but you have to go to like 10 or 11 decimal places, and nobody's going to write down 10 or 11 decimal places every time they write down 6.02 blah, 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 blah. So we use the 3-digit version, okay? This is exact. This is exact. And this is exact. And so we would now need to round this to 7.22 times 10 to the 24. Am I done now? I need my units. What are my units? Only thing left that's not canceled out is O atoms, and be kind to your teacher and put a box around your final answer, okay? Would we like another example? How about we do number 3, okay? Let's go do number 3. That's on page 21. How many moles of dinitrogen tetroxide? So what's the formula for dinitrogen tetroxide? N2O4. So we want to know the number of moles of N2O4. That's what we don't know. And we are given 1.204 times 10 to the 24 oxygen atoms. Atoms is on the next line. I'm sorry. I should try not to have that break over a line. It's confusing. So this is our initial quantity. So I'm starting with the number of O atoms, and I want to finish with moles of N2O4. Can I go directly there in one step? No. In between, I have to take the number of O atoms and I have to convert it into the what? The number of molecules of N2O4. And from there, then I can convert it in a second step into moles of N2O4. So let's try this, shall we? We want to find the moles of N2O4. We are starting with 1.204 times 10 to the 24 O atoms. And I feel like I might need to like write my calculation on a couple of lines because I'm running out of room a little bit. So here I have my first conversion factor. Well, maybe I'll just make them small. What am I canceling here? The atoms, the O atoms. And what am I finding? Am I finding moles? I am finding molecules of N2O4 molecules. And that's a nice easy conversion. There's only not two O atoms. There's how many? Not two, there's four. Four O atoms in one N2O4. And now we want to cancel N2O4 molecules and find the moles of N2O4. When we're going from moles to particles, whose number do we use? Avogadro. Okay. And what's his number? 6.02 times 10 to the 23. Where does that go? Does the 6.02 times 10 to the 23 go on the top or does it go on the bottom? It definitely does not go with the mole. That would be like saying 12 dozen, okay? 12 dozen is equal to 1. That's not the case, right? So the 6.02 times 10 to the 23 does not go with the mole. The 1 goes with the mole. And then our 6.02 times 10 to the 23 goes down below. Check and make sure you can get that on your calculator working nicely. Make sure you haven't forgotten how to use your exponent button. If you did not successfully get, when you plug it in your calculator, 0.5, call me over and I will help you with your calculator. Yes? Calculator? Yeah. Alrighty. Am I done? No, what do I need? What's the first thing I need? Sig figs, how many? 3, because I got that 6.02. I got this other one that's got 4, but I'm limited by the 6.02. So I need another 0, right? To give me 3 sig figs, is that right? Is that 3 sig figs? No, remember these zeros are not significant. Zeros on the left are not significant. So I have to have 0.50. That now gives me 3 sig figs. And now I need, finally, my unit, which is the only thing that's left after cancellation, which is moles of N2O4. Okay. Do you feel like you could do some practice on pages 20 to 23? Yes? Yep. For those of you who are going to Mountain Madness tomorrow, you are going to watch a couple of Tyler videos, which is what we'll do in class tomorrow if you're not going to Mountain Madness. So there's a 10-minute and a 13-minute. So you have pages 34, 35, 36. Actually, just pages 34 through 39. Okie dokie. So for those of you who are here, that's what we'll do tomorrow. If you're not here tomorrow, it's totally fine by me. Because there's enough people missing that I don't want it to be like you can't learn it on your own. It's math and it's Tyler helps you out with the math. Okay.